Hello everyone. In the last lecture, you learned about the in-stream flow incremental methodology and PHABSIM. These have been the standard for in-stream habitat modeling for more than 40 years, and the approach has been modified and updated in different ways through the years. But it's also been subject to criticism. A recent critique on the approach was published in December 2016 and prompted written comments from some of the leading scientists associated with IFIM and PHABSIM. So we're going to devote some time to this week and see what we can learn. My purpose now is not to lecture, but only to introduce the debate and highlight the key positions on both sides. You'll learn the details from the reading. Stephen Railsback is an environmental modeler at Humboldt State University in California, and he's also in a private company that provides consulting services in natural resources modeling, research, and management. He was trained in the use of PHABSIM in 1979 and applied it for a number of years. But over the past 20 years or so, he's mainly been a critic of PHABSIM. Recently, he published a new critique of the method in a paper called Why It Is Time to Put PHABSIM Out to Pasture. For those of you not familiar with the expression, to put something out to pasture means to stop using it. In this case, because of Railsback's opinion that it is obsolete and better options exist. Let's look at his main criticisms. First, he notes that PHABSIM is a habitat selection model, which he explains are models developed by identifying via statistical modeling the types of habitat that are selected by the organisms of interest, and then analyzing how the availability of selected habitats varies among management alternatives. He notes that there's been great progress in the development of habitat selection models over the past decades, but mostly focused on terrestrial systems, and he says that PHABSIM is now antiquated and not very good. His rationale is listed on the slide, so read the paper for details about each. Second, he notes that even if converted into a better habitat selection model, these models are not well suited for modern in-stream flow assessments. He notes that modern assessments focus on dynamic flow regimes, but habitat selection models cannot address habitat variation through time. Moreover, even the variables affecting habitat preferences change through time, like changing temperatures or turbidity levels at a given point in a river with otherwise steady depth and velocity. This variability is difficult to handle in habitat selection models and commonly ignored. He also cites study results that challenge the fundamental assumption in habitat suitability models that the habitats in which organisms are observed are their preferred habitats. He presents 7 interesting reasons for why this might not be true. Finally, he points out that the output of habitat selection models are not easily transferable to values that are meaningful for management. Railsback includes 3 recommendations for the way forward in a world without PHABSIM. First, he advises in-stream flow scientists to take a broader ecological view of flow needs, going beyond depth, velocity, and substrate. As an example, he suggests considering variables that affect food production, such as area of riffles in the reach or the transport of nutrients. Surprisingly, he continues to support the use of habitat selection models provided they are used under more appropriate conditions that he describes, and that they use more modern methods than those in PHABSIM. And finally, he suggests more use of individual-based models, which is a specialty area of his, as demonstrated by the books on the slide. He explains that individual-based models simulate populations by representing individual organisms, like fish, and how they do things like select habitat, feed and grow, survive or die, and spawn. He goes on to say that individual-based models are dynamic, often operating at time steps of 1 day or less, so they can predict how fish populations or communities respond to variable regimes of flow and temperature. He admits that individual-based models also have their drawbacks, but clearly feels that they are an improvement over the current use of PHABSIM. You'll find 2 published comments on Railsback's paper. The first is by Hal Beecher of the Washington State Department of Fish and Wildlife. He began working with PHABSIM at the same time as Railsback. Beecher begins by noting a weakness of PHABSIM that Railsback did not raise, that it's a one-dimensional model and not able to simulate important two- and three-dimensional dynamics. He also agrees that Railsback raises valid criticisms, but as his quotes on the slide illustrate, Beecher does not think of PHABSIN as a singular tool or approach. He views it as one element of the in-stream flow incremental methodology and reminds us that IFIM, as you also heard from Professor Martinez-Capel in the last lecture, is a framework capable of incorporating a wide range of information and knowledge to arrive at appropriate and implementable eFlows recommendation. Beecher goes on to address Railsback's more specific criticisms, noting that agencies using PHABSIN have developed standard procedures to minimize the scale effects, and pointing out examples where weighted usable area has served as a useful index. Beecher is open to new and improved approaches and says that if they work better for answering management questions, they'll be welcomed by the in-stream flow community. But he also cautions against changing tools too quickly or repeatedly. From his position inside a government agency working on eFlow studies, he says that, quote, agency staff need tools that can be used consistently and produce results that make sense. They have neither time nor budgets to change tools frequently unless there is a persuasive case for doing so. He goes on to say that agency staff need to have relatively standard procedures to meet standards of transparency and consistency. Legal and policy factors also come into play. Rather than recommending that PHABSIN be put out to pasture, he suggests that new approaches and tools be first introduced and agency staff be trained in their use. He suggests that this process might win converts to new approaches, but for himself, he still thinks PHABSIN can be adapted to address relevant streamflow management fisheries issues. The next comment has multiple authors, but the lead author is Claire Stallnacher, who led the development of IFIM in the 1970s. The title of their comment is, "Don't Throw Out the Baby, PHABSIN, with the Bathwater." This is another common expression that means don't throw something good out when you're trying to get rid of something bad. Stallnacher et al. Used this opportunity to provide their own assessment of the status of stream habitat modeling and what they think the way forward should be. They lament that PHABSIN has risen to be considered as a method in and of itself, which was never the intention. They note that Railsback makes the distinction early in his article, but then seemingly loses sight of it. They thus begin their comment by putting PHABSIN back in its place among the elements of IFIM. It's designed to feed select information into the IFM methodology. As Stallnacher et al. Say, quote, the IFIM uses physical stream descriptions, hydraulic simulation models, and stream hydrology to produce time series of hydraulic habitat simulations and water temperatures for comparing alternative flow regimes. The purpose of PHABSIN is to determine which areas of the river surface are suitable or unsuitable for life stages by way of changes in depths and velocities. This is simulated at different flow levels in the hydrologic time series to develop a habitat time series. But Stallnacher et al. Agree that equal or more emphasis should be given to ecological processes of each flow level rather than only habitat usability. You'll find much of interest in the comment of Stallnacher and his co-authors. In the end, as illustrated in the quote on the slide, they agree that significant advancements are still needed in eFlow's modeling approaches, but they believe that more advanced approaches will still need the outputs of PHABSIN-like models that simulate hydraulic conditions inside of different habitats. Thus, PHABSIN and improved versions of the model should be preserved as a still essential component of overall eFlow's determinations. Railsback does have an opportunity to respond to the comments of the others, as you'll read in the final piece. You'll see that he's not convinced by their arguments. He feels the flaws in PHABSIN are such that it should be completely eliminated. So it seems the debate will continue, and there's lots for us to learn by following it. So read the material and share your opinions with the class in the Unit 10 forum. That's the end of this overview.